Welcome to another video about how to do stuff for our class. I am going to go over some of the homework for tonight, where we are the number 15 through 20 homework that I gave you. And you'll see that for 15 through 20, there is a basic function. We'll call this the base function, which is the function in terms of x. In 15, it's 2 to the x, 16, it's 3 to the x, 17, it's 4 to the x, and then 18, we go back to 2 to the x, 19, it's 1/2 to the x, and 20, it's 0.6 or 3/5 to the x. So each of those are fairly straightforward. So the first thing to do in this is to figure out a few basic things. So one basic thing we can know is that if x is 0, then the function equals 1 for 2 to the x, because 2 to the 0 is 1. So we have a point we can initially figure out at 0, 1. And then we can find another point pretty quickly at 1, okay, 2 to the first power is 2. So we have a function that's going to be going up to the right. All right, we can even get one more point very easily with this one, which is for -1. And for -1, you get 2 to the -1, and that's 1/2. So we have a point at 1/2 there. Okay, so it's not a very hard step to then also get points for -2 and +2. 2 to the second power is 4. X is 2. Y is 4. And on the other side, 2 to the -2 power is going to be the reciprocal of 2 to the second. So 2 to the -2 power is 1 over 2 squared, or 1 over 4. So we now have 5 points we could plot. Okay, so that's great. We have what we need to plot a graph for number 15 for the f of x. Now you're going, well, what do I do about this x minus 3? Well, what this means is if it's x minus 3, we're going to have a different effect. So we're going to be shifting our function just a little bit. So one way to approach this is to figure out what x value would make 2 to the x minus 3 the same as 2 to the 0 power. So we want to figure out what would have the same effect of as for 2 to the x, what would have the same effect as this 0 in the x position? What would raise this 2 to the 0 power? Well, x would have to be 3, because 3 minus 3 would be 0. So we can start with a point here at 3. And that'll have the same effect as 0, because 3 minus 3 is 0. So 3, 1. Okay, what would have the same effect as having this be 2 to the first power? Well, 2 to the first power is going to be, to get 2 to the first power, we're going to have x be 4, because 4 minus 3 is going to be 1. So I'll go ahead and plot 4. So 2 to the 4 minus 3 is 2 to the first power. So I'll have that be 4, 2. So now I have another point. Now, what you might be noticing is that it's the same y values, but the x value is shifted over by 3 places. And that's because the x value has to be 3 places bigger for x minus 3 to have the same effect as just plain old x. And that's a principle you can use with this. For all of these, if you can think systematically about how you can adjust your table of values, it'll work out very nicely. Once again, let's try this out. Maybe the pattern works for this. Instead of going from -2 to +2, it goes from, we started with 0, have, 0, 1, we get, with g of x, 3 has the same effect as 0. So maybe instead of from 0 in the middle over to 2, we've got 3 in the middle over to 5. So 5, let's see, will 5 have the same effect as 2? Well, 5 minus 3 is 2, so that is the same as 2 to the second power. So 5, 4 is the point. You might start seeing a pattern here, and I invite you to be considering the patterns that might be showing up here. So, all I'm doing is I am taking a look at this exponent of x minus 3 and seeing how the minus 3 affects it for each one of these y values, how it gets me to the same y value. And to get me to the same y value, I've got to make the x minus 3 itself equal to these base exponents of -2, -1, 0, 1, and 2. All right, so I'll end up with, so instead of, I'll go back in steps, so x equals 2 and x equals 1. So if x equals 2, 2 minus 3 is -1, so I'm going to have the same effect as -1. 2 to the -1 is going to be 1/2. And now I've got 1 as an x value. So if I plug in 1 here, 1 minus 3 is -2. Well, I'm going to have an exponent of -2 over this base of 2. So I'm going to be at 1/4. So there I have it. I have a set of points. And what's happened is I've got the same shape of the function, but all my x values are 3 to the right. So we can graph this. So I'm going to go ahead and copy this over into my Desmos space. I was very happy with that. And then I'm going to copy over these points. You can get a sense of what it looks like. Okay, and it basically rhymes. So if we put in the function itself, so notice that every single point has this corresponding point, 3 over to the right. Okay, and so we're going from our y-intercept at 0, 1 over to 1 over to 3, 1. So our x value changed by 3. So each time I go over by 3, and that's what that x minus 3 ends up doing. So I've got 2 to the x, and down here I've got 2 to the x minus, I'm going to have to put parentheses around that, or Desmos is going to think I'm dropping down again. So 2 to the x minus 3, and voila, you have it. Okay, I'm going to stop this one right now, and I invite you to see what you can do with the rest. I'll make a couple more videos, and you can check them out as well.